Welcome again. Now let's review what we have learned in the previous video. We have actually discussed the point slope equation. So it looks like y equals y1 plus m times x minus x1. That's what we have learned. And now let me draw a Cartesian coordinate system here. This is the y-axis, this is the x-axis, and there is a line called L. And consider that L crosses the y-axis at B. So this is the 0B point, and it crosses the x-axis at A. So this is A 0 point. And now the y-coordinate of the point where a non-vertical line intersects the y-axis is called the y-intercept. So this point is the y-intercept. And similarly, the x-intercept of a non-horizontal line is the x-coordinate of the point where it crosses the x-axis. So this is the x-intercept. Now, a line with the slope m and y-intercept b passes through the point 0b, so it has an equation like y equals b plus m times x minus 0, or more simply just m times x plus b. And now why it's equal to this? Because if you substitute the 0b point into the point slope equation, then you get this equation, and we call it the slope intercept equation. So the slope intercept equation, and it's really useful. You will realize that later. Now let's see generally. Okay, so there's an equation, the big A times x plus big B times y equals c, and A and B not both 0. This is called the general linear equation. So this is the general linear equation. And in x and y, because its graph always represents a line, and every line has an equation in the form, including lines with undefined slopes. So it's another useful formula. Now let's see an example. So find the slope and the y-intercept of the line 8x plus 5y equals 20. So to solve the equation, just simply solve the equation for y to put it in slope-intercept form, because then the coefficient of the x is the slope. So it's really easy. Now subtract 8x from both sides, so you get 5y equals minus 8x plus 20, and then divide both sides by 5, so you get that y equals minus 8 over 5x plus 4. And now that is the slope-intercept equation of the line. So you can see that the coefficient of x is the slope. So here comes that m equals to minus 8 over 5, and b, which is the y-intercept, is 4. And that was the whole problem. I hope you understand this. Now let's talk about distances. Now I need some more space. Now I want to draw circles in the plane, but first we need to be familiar with the distance between points in the plane. So let me draw you a Cartesian coordinate system again. Here is the y-axis, and here is the x-axis. And now here is P point with the coordinate pair of x1 and y1, and here is the Q point with the coordinate pair of x2, y2, and I want to know this distance. Now I draw a parallel line with y through Q, and I draw another parallel with x axis through P point. So now I've got a new point called C with the coordinate pair of x2 and y1. And now PCQ is a right-angled triangle. So this is the right angle. And as you can see here, this is x2 and this is x1. This is y1 and this is of course y2. So as you can see here, this is the delta y, so the increment in y. So it's y2 minus y1 equals delta y, and this is the delta x, so the increment in x, that x2 minus x1, that equals to the delta x. And if you've started calculus, you should be familiar with the Pythagorean theorem. So we got that the PQ, so the length of the PQ is equals to the square root of delta y squared plus delta x squared, or the square root of y2 minus y1 squared plus x2 minus x1 squared. Now this is the distance between the 2 points, so this we call d, and this is the general formula for the distance between 2 points. Now calculate the distance between I don't know, p minus 1, 2 and q 3, 4. So calculate the distance. Never so easy. Why? I just visualize you. This is another coordinate system, y, x. So here is minus 1 and 2. So here's the P point, and 3, 4. This is going to be Q. And now we are interested in this distance. Now we should calculate the increment in y and the increment in x. So the increment in x is 4, as we can see, because it's 3 minus 1, as you can see here. And the increment in y is 4 minus 2, so it's 2, as you can see here. Now the distance equals to the square root of the delta x and delta x squared, which is 16 here, plus the delta y squared, which is 4 here. So this is the square root of 20, which is 4 times 5, and that is 2 times the square root of 5. And that is the distance between these 2 points. Now calculate the distance. I just make some more space again. Okay. Now calculate the distance from the origin to pxy. So we got a pxy, and we want to know the distance from the origin. So the distance will be equal to the square root of x minus 0 squared plus y minus 0 squared. And that is the square root of x squared plus y squared. And that is the distance from the origin. By definition, a circle of radius a is the set of all points px, y, whose distance from some center, called the center C, hk, equals a. From the distance formula, p lies on the circle if and only if the square root of x minus h squared plus y minus k squared equals to a. Or you can actually square both sides, so you get that x minus h squared plus y minus k squared equals a squared. And this is the standard equation of a circle with the center hk and the radius a. The circle of radius a1 is and centered at the origin is the unit circle with the equation x to the second power plus y to the second power equals 1. Okay, so x plus y squared equals 1. That is the unit circle. And it looks like this. It's 1, 1, minus 1 and minus 1 here. And the equation like x minus h2 squared plus y minus k squared equals a squared is the equation of the circle that looks like this. Another Cartesian system, coordinate system, and this here is a circle with the center of hk and a radius of a. So that is. So this is the circle with this equation. This is how it looks like. Actually, you can easily prove it with the Pythagorean theorem. Okay, so we will continue with more examples in the next video, but it will be enough for now. Bye bye.